Hello, smart people. Let's quickly work on this homogeneous problem. So because of the length of this problem, I may want to divide this board into two like this. So let's use this part. So what's the first thing you need to do? I will just say, let y be equal to vx. Some textbook like a K Strud, HK does, it uses vx, y equal to vx. Some uses ux, but just about your choice. So let's make this equation 1. If this is equal to this, then we have that the derivative of this y with respect to x will be equal to, let me just show you, let me prove it. We just want to keep v constant and take the derivative of this x with respect to x, plus this time we need to keep x constant and take the derivative of this v with respect to x. So if we are able to achieve this, the x will cancel out. Therefore, we have dy over dx equal to v plus x dv over dx. Let's make this equation 2. So these are the two parameters we need to solve this problem. So firstly, we need to substitute vx for this y. So we then have the original equation dy over dx equal to, we have x plus 3. In place of this y, we substitute with the vx all over 2x. Does that make sense? Of course, if you look at the numerator, you will notice that x is common to both sides. So if factor out x, we left it 1 but not 0, because x times 1 is x. Plus, if you pull out this x, what you'll be left with is 3v, all right, all over 2x. Because the numerator is a function of multiplication, x multiplies by this, and then 2 multiplied by this, it is easy to accept that x can easily cancel out with x. So leaving us with, keep in mind, keep writing this dy over dx, leaving us with dy over dx equals 1 plus 3v over 2. All right, so what do we need to do? Let's substitute this equation 2. Remember, this is dy over dx, this is dy over dx. In place of this dy over dx, we substitute this one to replace this. So I'll have this to be v plus x dv over dx equal to 1 plus 3v over 2. So what we need to do at this point is what we call separable variable or separation of variable. So we need to make sure that all that has v terms contained in it to be on the right hand side of the equation. The one that have x should be has x should be on the left. So what do we need to do? We have x dv over dx equal to 1 plus 3v over 2. If you subtract v from both sides of the equation, or the way they easily say it, taking v across to this part, it becomes negative v because it was positive here. I like it when you just say subtracting v from both sides of the equation, so it cancels out here, then have negative v on this part. All right, we can make this to look like this fraction. After all, v divided by 1 is something as v. Does that make sense? All right, so let's look for the LCM of the denominator. All right, so we have x dv over dx equal to the LCM should be 2, right? If 2 goes, oh, let me take this up because you probably may not be seeing this one. So let me scrape this out. All right, let's take it off from this point. So what we have here is x dv over dx equals, the LCM of 2 and 1 is 2. All right. So what happens if 2 goes into 2? That will be 1. 1 multiplied by 1 plus 3v will be 1 plus 3v minus 1 goes into 2. That will be 2. And then 2 multiplied by v, that will be 2v. All right, so let's make progress. X dv over dx is equal to 3v minus 2v. That will just be v plus v over 2. Okay, so what do we need to do? We are still on the separation of variable. All right, so what we need to do, to keep it simple, let's multiply, cross multiply. If 2 multiplied by this, we have 2x dv equal to dx multiplied by this, we have 1 plus v dx. I just want to show you the process instead of just doing magic, all right? So what do we have to do, right? The next thing we need to do is to divide both sides by 1 plus v. 1 plus v. This will easily cancel out with this. We can as well divide. Okay, let's write what remains. So the next time we're going to divide both sides by x. That way we will easily separate the variable. So if we divide both sides again by x, so that this x cancels out with this, we'll be left with 2 over 1 plus v dv equal to 1 over x x. All right, because 2 times dv, excuse me, 2 times dv, that will give us 2 dv. 1 times the x, that will still give us the x. So we are still on the same plane. Now, if you notice, we've separated the variable. So what x? Immediately to finish with separation of variable, what you need to do is to integrate. So let's add integral sign to 2 all over 1 plus v dv equal to the integral of 1 over x dx. And of course, I need you to know that this 2, which is constant, can come in front of the integral sign, so that we have 1 over 1 plus v dv equal to integral of 1 over x dx. But I need to note that the integral of 1 over 1 plus v is equal to ln 1 plus v. Maybe we want to put it in bracket or modulo sign. Also know that the integral of 1 over x with respect to x is equal to ln x. Okay, so here we'll be having 2 ln 1 plus v equal to ln 1, okay, that's x, because we have only x on the denominator, plus constant c, all right, which is the constant of integration. Okay, according to logarithm law, power law, if you have these 2 at the power, we can still bring it in front of the logarithm. If you have it in front of the logarithm, we can still take it to the power. So let's take it up. So we have 2 ln 1 plus v all squared minus, let's take this one to the left hand side, ln x equal to this c. Because we are having ln everywhere, we can say let c be equal to ln a. We can replace this c with ln a so that we have the same ln everywhere. Okay, so according to the division law of logarithms, when you have negative, you divide. So because the ln are common, I'll just take one of the common ln and divide 1 plus v all squared all over, we have x here equal to, here what do we have? We just have ln a. So ln and ln can cancel out at this point. So let's remove this, some part of this stuff we have here. Let's remove this part so that we can be able to finish the remaining process. Okay, all right. So when this cancels out, what is left is 1 plus v all squared over x equals a. So if you cross multiply this, what will be left? You'll be having 1 plus v all squared equal to xa. But remember that, recall that you made an assumption here. Y should be equal to vx. So if we make v the subject of the formula, we have y over x. How? Divide both side by x. Divide both side by x. S will cancel, leaving us with v, which will be equal to y over x. Remember, the equation did not come with v. We introduced this one that has v. So we need to remove that v that we introduced to the function. So at this point, anywhere you see v, replace with y over x. So we have 1 plus y over x all squared equal to xa. This implies that at this point, if you check this point over 1, the LCM of 1 and x is just x. So 1 going to x is x. X times 1 is x. Plus s into x is 1. 1 times y is y. All squared equal to xa. So what will be the next point? This square is affecting both the numerator and the denominator. So you can still write it as x plus y all squared all over x squared equal to xa. Therefore, finally, if you cross multiply, here is over 1. 1 times this, same thing as x plus y all squared equal to x squared times this will be x cubed. And this is the final answer to this problem. I hope you found this video helpful. Make sure to like this video, share, and hit the subscribe button if you've not subscribed to my YouTube channel. Turn on the notification bell so that when I upload new video, you receive notification. And I'll see you in the next video. Peace out.